Hello, my name is Aiden McGuire. I'm a senior and I did image quilting or texture synthesis. So first things, big idea, what is texture synthesis? Well, if you have this image on the left and you want to get this image on the right, how do we do that in a way that is convincing? The naive approach is just to take patches from the source image and tile them just in order. And that predictably leads to these very obvious grid lines. You can see the borders between those patches. And so the problem for us is how do we get this image in the bottom right? How do we make the patches blend together and look like they were put together naturally? So I implemented this algorithm in 3 steps. Again, that's the original source image of just a brick wall on the top left. And the first way we might do this is just randomly applying the patches. This looks pretty terrible, obviously, but what this method is doing is just taking a patch from the original source image, putting it in the top left, and then another random patch, putting it next to that, and so on. And it arguably looks better than this one. Well, maybe that's just due to the textures. I don't know. It looks really bad regardless. But we can get a massive improvement by instead of just taking patches randomly and being random with which patch we choose, we're actually intentional. So in this method, each patch is overlapped on top of the previous patch. And the pixels overlapping from the two patches are meant to minimize the sum of squared distances um, of the pixel values themselves. And what that results in is very clean borders. It looks like these are not two patches from two separate parts of the image. They look like they blend together very nicely. But there are still some artifacts, and we can improve that with the final method, which is instead of just overlapping those two patches with a vertical line, if you think of two pieces of paper, one on top of the other, we can actually find the ideal seam between these two patches based on, again, minimizing the cost. So here, a light pixel means there is a big difference between the values of those two pixels, whereas a dark pixel means that there's a very minimal difference between the values of those two pixels. And so this algorithm tries to find the ideal cut through the two overlaps so that they line up on the seam and then it looks the best. So here's some more photos of the results. On the left here, this is the chicken over fries from White Sauce Grill. They opened on Franklin this semester and have been one of my favorite places to go eat after class. So, had to rep them. And then this is just some bread. Um, both look pretty good, I think. Challenges. So this is an example, the raspberries are a good example of this when the size of the pixels, how many pixels you're using for the patch is not big enough to capture, the basic feature of the image. So here we have like half raspberries. It looks like they've all been ripped apart because our patch size is not big enough to actually represent this texture well. So that's one thing you have to watch out for. The images were sourced from Wikipedia Commons, to stock photo websites, and then again, that was from White Sauce Grill. You should go, not paid by them, but I just like it. Thank you.